for Irina Guberman. Join me in welcoming Irina Guberman. We're going to take a minute here to set up.
Thank you. Long, long ago, in a galaxy far, far away, a lonely software engineer named Irina came up with a social networking website idea that she thought was really cute and sweet and cool, compliments as a service. And she called her imaginary social networking website Kudos. She imagined millions and millions of users flocking to her amazing website. Who wouldn't want to give compliments that everybody can see online, or receive compliments that everyone can see online? Collect compliments, send compliments as birthday gifts. Yes, millions and millions of users. But back to reality. Kudos, the website, was yet to be created. Irina, a backend Java engineer at the time, was already working at a company serving hundreds of millions of online users. To her, a backend Java engineer, that's what Kudos really looked like. Her very own Java web server. So scary. She knew what it takes to create and support a busy web server written in Java, one of the most popular languages of our time. A Java server is a monolith. And by the end of this presentation, you will know what I mean. Something unpredicted happens, and the whole thing collapses. You have to be very careful dealing with exceptions in your code. Or before you know it, the server goes down, and you lose clients and money. But let's not jump too far ahead of ourselves. Luckily, the place Irina worked at had an established business model, a solid client base, and a steady cash flow. They could afford losing thousands of dollars during server downtime. They could also afford hiring very expensive, experienced developers to deal with all the challenges that Java presents in the context of a busy web server. So Irina was trying to start a startup while working at a startup, and she faced two serious limitations as old as money. Time. She needed time to create the Kudos web server, and she needed money to run that. She needed money to run that. She needed money to for the hardware to run the software on. So let's talk about money first. I know time equals to money, just like E equals mc squared. Who here tried turning mass into energy? Well, we know it's not easy. Similarly, turning your own time into money is not trivial. As equal as they might be, to start a company, you actually need money before you can turn time into money. And you will need, so for a web server, you need CPU and memory to process and serve the web requests. And you need a database to save the user data. And the more efficiently your web server operates and uses these resources, the cheaper it will be for you. Of course, modern-day startups have an amazing option available to them. They can run their software in the cloud. But anyone tried registering for Amazon Web Services free tier? You have to take out your own credit card out of your own pocket. And it's nothing like your infinite corporate credit. Think about it for a second. And then another great benefit of efficient and scalable software is performance. Actually, every time a discussion on performance comes up, its nemesis, the discussion on premature optimization, appears. But in the context of a web server, I don't even think it's a worthy discussion. Anyone here enjoys waiting for a web page to load? You know how many shoes I almost bought online because the checkout page took forever? Well, if you don't, if this is not convincing enough, just if you want real statistics, just Google this. And now let's talk about time. Not space-time, not CPU time, Irina's personal time, the time she needed to develop the Kudos software, and not just the very efficient and scalable backend, but also good-looking front end. And just to get the angel investors and her programmer friends interested, she needed to develop some kind of web server prototype. So lots of work. And she knew that this Kudos business will be hard. But seriously, everything is hard. Even making lasagna is hard. But one goes to a store and buys this, and this, and making lasagna becomes a reality even for a stay-at-work mom. Modern-day cooks have lots and lots of great abstractions sold to them at the grocery store. Buying this, we buy time and knowledge and experience in a jar. Today, I don't think software abstractions, talking about frameworks, high-level languages, and even design patterns, are as far ahead as cooking abstractions. They exist, but that software jar is so much more likely to explode into your face. Besides, software abstractions sometimes are so hard to learn and figure out how to use with your particular situation. So sometimes you think it would have been just easier to write the whole thing in C, cooking equivalent of from scratch. A lot of developers get frustrated with frameworks and third-party libraries and with new, higher-level, arguably better languages that in the end, they get themselves in so much trouble with them that in the end they think that they'll never use one again. Nonetheless, striving for abstractions is in the nature of all intelligent progress. We cannot constantly reinvent the same old stuff. We have to move on. That's why new software abstractions get created all the time. Some of them are very powerful, useful, and reliable. And some are easy to learn. Some address very specific problem space. Some are born in such favorable conditions that when there are no better alternatives out there, that they gain popularity completely unproportional with their value. Due to sort of a snowball effect. Some abstractions take us 2 steps forward, some take us 1 step back. So we can say that software abstractions undergo some kind of evolutionary process. Unfortunately, survival is not determined by the software professionals alone. Very often, recruiters and high-level managers and people of power, but without the knowledge of software, take a big part in getting the snowball rolling and helping mediocre or downright useless abstractions gaining popularity. And software engineers just go along with it. I wish they didn't. But to be on a positive side here, I'm really curious what abstractions will be like 10, 20 years from now. Maybe we'll have them so powerful that little kids will be able to build complex software architectures with a cute visual app on their iPhone 26s, or whatever the unimaginable holographic display gadget they'll be playing with. So, dear fellow software engineers out there, if we want great future for our industry, let's be picky and choosy and take control. Let's look at Irina's example. She had to be picky and choosy. She had no other choice. But her example is a good example nonetheless. So she did not, for her own web server, she did not consider Java. The language she knew so well, and the language that fed her and her family for so many years. And why not? So, okay, she needed this highly scalable parallelized web server. What about Java concurrency package? Well, unfortunately, Java concurrency package does not protect the developer from the perils of concurrent programming. If anything, it makes concurrent programming look deceptively easy and more appealing, but not any less dangerous. If you happen not to be very familiar with what concurrency programming is, I strongly encourage you to go ahead and try it for yourself. Use C, C++. Go ahead, try using Java concurrency package. Play with it long enough, and you will understand this is something you don't want to be alone in the wild. Human brain is not designed to operate concurrently. That's why experienced programmers want to avoid concurrency programming altogether. We don't want fancy tools to roll our own concurrency. We just want to avoid it at all costs. So there are a few programming languages out there that actually take the concurrency programming off of the developer's plate altogether. We'll look at them in just a moment. But before we do, let's take a look at some very important considerations for our web server. Mutability and shared state are the biggest enemies of proper concurrency. Just trust me on that for now, but Google it later. I actually wish that Google developers Googled it before developing Go. A program written in a language that allows mutable variables will inevitably end up with a deep down broken concurrency model. And that will cost you. And no matter how hard you try to enforce immutability in your own concurrent program, mutable variables will pop up somewhere, whether it's going to be a third-party library or your own piece of code you wrote on a Friday night. But let's say by some miracle you actually managed to write and maintain a 100% immutable program using mutable language. You know, that is actually very, very hard. And in case you haven't gotten the gist of this presentation yet, this is exactly what we are trying to avoid, the hard work. And the next very important thing we want for our web server is fault tolerance. We want our server to be up and running even in unpredicted circumstances, despite bugs and unexpected requests and such. We don't want it to be ever down at all, because when the server is down, we are losing clients and money. So in my humble opinion, the biggest enemies of fault tolerance are monolithic structures of any kind. And we are going to talk about a very specific one. Java virtual machine. Java virtual machine has monolithic heap shared between all the threads. Because of that, killing a bad thread actively running on the JVM is impossible. It is not allowed. We are risking to corrupt the heap. And the bad thread has serious potential of taking your entire server down, along with all the good threads processing all the good requests. So we'll be losing clients and money. Another bad side effect of this monolithic heap is a monolithic garbage collector. Obviously, it takes monolithic garbage collector to clean up the monolithic heap. And with that monolithic garbage collector, we are going to end up with long garbage collection pauses. Again, losing clients and money while not being able to serve requests. And a lot of you probably here will argue that the garbage collector can be fine-tuned. Yes, you can fine-tune the hell out of it, and it will not be causing garbage collection pauses. But that's, again, very hard work, very experienced and expensive engineering. So if we want really a fault-tolerant system, we want it to look something like this. Tiny isolated processes with its own isolated heaps. One process goes crazy, it gets killed, the rest of the system runs happily alone. And in my humble opinion, again, no garbage collector. It's a runtime burden that could be taken care of at code compile time. That's just my opinion. So now let's talk about some fun things. Concurrency abstractions. So we'll look at two most popular models. I think they're most popular. Actor model designed by Carl Hewitt in 1973, and communicating sequential processes model, designed by Tony Hoare in 1978. So one little remark to compare the two of them. With either one of these two concurrency models, processes don't use locks and mutexes to access shared information. Instead, information is passed between processes. It's known as the concept of message passing. Actor model is very similar to how we humans operate. For instance, if I want to communicate to my husband on his way to, he's on his way to a grocery store. If I want to communicate to him the grocery shopping list that's in my head, I don't lend him a part of my brain that has the grocery shopping list while he's at the store. I simply communicate the list to him, and with any luck, it ends up in his brain. Communicating sequential processes are slightly different. They actually, the information is passed through channels, and it's not intended for a specific recipient. In my humble opinion, they're a little more monolithic than the actor model. I personally like the actor model way more, and it's, in my mind, is much more fault tolerant. So now let's take a look at some concurrency abstraction implementations. So communicating sequential processes, we have Go, developed by Google. We have Clojure core async package. And now we even have Java CSP. I just learned about it while preparing for this presentation. So actor model, we have Akka, written in Scala, and then we have Erlang. So let's, considering fault tolerance and immutability, let's take a look at those languages and see which ones of them fit our needs. So Go. Go is a mutable language. So Go is no Go. Clojure, it's a language running on the JVM, and we talked enough about the JVM today. So no to Clojure async package. Java CSP, needless to say, JVM language. Akka Scala, I like actor model, but it's running on the JVM. Erlang. Back in 2011, Irina became aware of a rare treasure that had actor model implemented and concurrency beautifully abstracted away from the developer. Its variables are 100% immutable in nature and hence 100% safe for concurrency. It offers complete process isolation with each process holding in its own heap, and hence ability to kill a bad process programmatically. With it came another great abstraction. OTP, Open Telecom Platform, offering common behaviors like server and finite state machine out of the box. The treasure was battle-proof in many production environments, demonstrating 9 nines of uptime, and in some cases, years of uptime. For Irina, it was a very good news because it meant her CUDA's backend could be created without investing into expensive developer resources, and it can be CPU efficient and can be run with minimal human support because Erlang has built-in supervisors. And they have the power to kill and restart misbehaving processes in a fully programmable way. For Irina, who I have to say was a very lazy person, and she liked to sleep at night, it was purely priceless. Powerhouse of really useful abstractions created by 50 or so brilliant Ericsson employees over the course of 5 years. Perfectly suitable for a busy web server. And just like the stars in the sky are absolutely free. And though unlike the stars in the sky, readily available for download. And Erlang is a functional language. In case some of you software engineers out there haven't noticed, our world is slowly but surely is gravitating towards functional languages. Since the times of Democritus, the scientists and philosophers have been discovering smaller and smaller basic particles that the vast diversity of our world is made of. Yet they keep looking to possibly discover the one and only. Modern quantum physicists are striving to describe all fundamental forces and the relationship between them, elementary particles, in terms of a single theoretical framework, known as unified field theory. Best of luck to you quantum physicists. Software engineers, software scientists, however, already discovered their unified field theory. Functions are our fundamental forces. And here's a brilliant proof. I found it on Twitter. That's where I get most of my information. Let's compare some object-oriented patterns and principles to their functional counterparts. So let's go ahead. Single responsibility principle, its functional counterpart, functions. Open-closed principle, functions. Interface segregation principle, functions. Factory pattern, yes, functions. Dependency inversion principle, functions also. Strategy pattern. Oh my, functions again. A little historical perspective. Functional languages were too slow back in the days when hardware had only a fraction of modern hardware power. So imperative languages at that time naturally took over, despite their all-around inferiority as far as usability goes. They are faster and they took over. Imperative language proliferation, it has purely historical reasons that are no longer hold true. That no longer hold true. So if anyone doubts that the future is functional, just look at Java 8. This very popular object-oriented dude is now wearing a functional hat. I guess it knows that's the only way to survive. So Erlang. With Erlang in mind, CUDA's ideas started looking much more approachable. Something like this, probably. However, for someone who never created a website from scratch before, it would have to begin with more like this. And that seemed a little trickier. So Irina realized she needed a powerful web framework. She needed a lot of common web functionality out of the box. CUDA's would be quite possible in her situation if she had both a powerful language and a powerful web framework. Maybe something like this. She definitely had resources to build something like this. So she started looking for a good web framework to go ahead with the CUDA's web server. So this is a couple of, here are a couple of things she analyzed. Ruby on Rails. She've heard about Ruby on Rails and how folks could get a website up and running in a matter of a couple of weeks. One Ruby developer Irina spoke to loved Ruby because it's very powerful, extendable, thanks to its built-in metaprogramming abilities, maintainable, and all-around very pleasant language. But she's also heard that Ruby is slow, and all the pleasantries incur a runtime cost. And basically, when a website gets very busy and popular, all the slow bits are slowly being rewritten in C or Java. In her case, it would be Erlang. And to her, this whole thing sounded ridiculous. So it's like a punishment for success. Rewriting CUDA's just around the time when it became very popular. Very exciting prospect. Thanks, but no thanks. So she went on to looking at PHP, another very popular language in web development. It has a lot of web functionality built in. And compared to Ruby on Rails, PHP is not slow. However, it could be a maintenance nightmare. That's the most likely reason why PHP developers switch to Ruby on Rails and are loving it. So, maintenance nightmare. Thanks, but no thanks. If you don't plan for your web server to succeed, you don't care about it being maintainable. However, Irina expected CUDA's to succeed. Why else would she bother with it to begin with? Anyway, this kind of decision-making was happening long, long ago, in the year of 2011. It was a very imperfect world back then. And guess what happened to CUDAs? You got it right. CUDAs didn't happen. Trying to choose between a perfect language and a web framework combo was like sleeping with a short blanket. When you cover your head, your feet get cold. And when you cover your feet, sigh. That's actually a quote by Joseph Alim on CSS. I found it on Twitter. Well, anyway, it is now 2015. We live in a much better world. Joseph Alim didn't just come up with this awesome quote. He also created Elixir programming language. Built on top of Erlang VM and Erlang OTP, it has beautiful hybrid Ruby, Erlang-like syntax, and thus appeals to a number of Ruby as well as Erlang developers, and has naturally all the benefits of Erlang, including complete interoperability with any Erlang code and libraries. And now it's time for the cherry on top. Chris McCord built a fully featured web framework in Elixir. It does not sacrifice speed like Ruby on Rails or maintainability like PHP. Ultimately, standing on the shoulders of giants like the Erlang VM and Erlang OTP, it offers amazing scalability and fault tolerance for our web server. The name of the framework is Phoenix. You got it? Now we got it all. Call it the best of both worlds, or call it a perfectly sized blanket. This time around, CUDAs has a chance. This concludes my presentation. Thank you very much for listening. And now it's time for any questions you have. No questions?
Couple in the back.
Hello. I don't have a question. I just have a compliment. Great presentation.
Thank you. I have heard.
So I was curious if you've actually built the site and how did it work out?
No, I actually was going to build the site before this presentation so I can brag about it, but it turned out that 2 months was not enough for me, so I am actually thinking about it. And I also am not, I'm still not sure how exciting of an idea is this, and I actually suspect that the reason why I didn't build is not because there weren't tools around, and just because I'm not much of a visual website kind of person. I'm more of a backend engineer. So, but I might, since the tools are out there. It was a fairy tale, too, in case you haven't noticed.
Hey, Irina. Over here.
Oh, hi.
Hey.
Oh, hi.
Just wondering, so Akka does implement the sort of actor interface, and Scala allows you to define things as being immutable, or am I missing something? I'm trying to figure out what it was about the JVM that is inherently wrong or inherently not what you want.
So you said that Scala is immutable. But the whole point for Scala was actually, was that it's actually interoperable with Java. So basically, while Scala itself is immutable, so if you write a program in pure Scala and without letting any Java code in, it will be immutable. But the JVM, it has this huge heap. And basically, you cannot kill a thread on the JVM. So you'll have these little actors implemented in the with Akka and Scala, but you can't kill those. If something goes wrong, you cannot kill them. And that's the, you can't kill processes, you can kill threads in the, on the JVM. That's the ultimate limitation of the JVM. So, and yes, and you can contaminate your program with the mutable code because it allows Java very easily in. So if you use any Java libraries, you're open to the dangers.
Okay, thank you.
Any other questions for Irina? Discussion. Has anyone gone through this? I've gone through this many times. It's like this standard process of you need to go and find the thing, the right everything before you go build it. I can completely relate to that. I mean, has anyone had experience with Elixir here or an Erlang VM? It's very different. It's an interesting language. Any other questions? Somebody's yawning. That's not a question. Stretching, I'm sorry, not. Okay, well, thank you very much, Irina.
Thank you very much for listening.